Hi, welcome to Fun with Algorithms. In this video, I'm going to talk about Tortoise Hare technique, which can be used to solve certain linked list problems. And we will use this to detect loop in a linked list. Now let's get right into it. Okay, now let's see when this technique is used and why it works. So we know that in a linked list, one node is linked to the next one in the form of a chain till the last node, and if we traverse this list, once we reach the last node, the traversal stops. But if this last node is linked back to some other node before it in a linked list, then it forms a loop. Now if we traverse this list, once we enter the loop, we will be stuck in it. We will take advantage of this property to detect loop in a linked list. Now if we take two pointers, move one faster than the other, then it imitates two people running around the circle, one faster than the other. So they have to meet somewhere in the loop eventually, right? Now that means if there is a loop in a linked list, these two pointers meet. Else the pointer which is moving faster will reach null. Okay, now let's look at this in action to detect loop in a linked list. To start with, we take two pointers, Hare or H and Tortoise or T, after our favorite childhood story of Tortoise and Hare. Now in each iteration, we move pointer H by 2 steps and pointer T by 1 step. Now once both pointers T and H enter the loop, H starts getting closer to T as it's moving faster and eventually catches up with T. So with this approach, we will know that loop exists if H and T meets, and if they don't and pointer H reaches null, then list doesn't have a loop. So that's how this algorithm works. Now let's look at the code for this problem. So we have this code opened in VS Code. We have two files, list.go and loop.go. Now list.go contains basic list implementation. We have this node structure representing a node of a linked list and a linked list structure representing the list itself. I have created this method called getNext, which returns the next node but also handles null check while doing so, as we have to move pointer H by 2 steps and we don't want to get into null check issues. And in loop.go, we have the logic of detecting a loop. We first check the base case, if the list is null or the head of the list is null, or if list contains only one node. And if any of this is true, then there is no loop, so we just terminate the program and return false. If not, we make pointers H and T point to head of the list, and in for loop we basically check if pointer H is null. If not, we move pointer H by 2 steps and pointer T by 1 step, and then we compare if they point to the same node. If they are, we know that there is a loop and we return true, else we continue the loop. Now at some point, if pointer H points to null in the for condition of the loop, then we exit the loop and return false as there is no loop. So that's all about Tortoise Hare technique. Hope you have enjoyed the video, and if you liked it, please do like, comment, share and subscribe. And don't forget to press the bell icon to receive notifications on my new videos. Thank you.